Hi everyone. So in this session we will discuss weekend test 15 and I'll be discussing physics MPL paper with you, right? So let's start with question number 1. We have a circular coil of radius 4 centimeter and has 50 turns. So radius is given as 4 centimeter and number of turns are 50. In this coil, a current of 2 ampere is flowing and it is placed in a magnetic field of value 0.1 Weber per meter square. ठीक है. The amount of work done in rotating it through 180 degree from its equilibrium position will be. So equilibrium position over here will be when it is at an angle of 0 degree. Fine. Okay, and we are rotating it to 180 degree. So work done over here will be MB cos 0 degree minus cos 180 degree, right? So M is NIA, N is 50, I is 2 and A is pi r square, which is pi into 0.04 whole square into cos 0 degrees 1 minus of cos 180 degrees minus 1, right? So after solving this one, you'll get the value of work done as option 1, which is 0.1 joules. Next is question number 2. We have a wire of radius r having a cross section carrying steady current I, and we need to find the correct representation of magnetic field versus r. Okay. So when the point is inside the wire, magnetic field over here is given as what? Mu naught I r upon mu naught I r upon 2 pi r square when the point is inside. So you can clearly see that it is directly proportional to r, and when the point is outside it will be mu naught I upon 2 pi small r. Okay, so when point is outside, magnetic field is inversely proportional to r. So this will represent a straight line and this will be your hyperbola. So correct answer is option 2. Next is option 3. Question 3, we have a current I flows along the length of an infinitely long straight thin walled pipe. Then magnetic field is 0 only on the axis of the pipe. Thin walled pipe, it is something like this. So inside there is no current, right? So magnetic field inside will be 0 according to Ampere's circuital law, that line integration of B dl is equals to mu naught into I, which is enclosed inside this Amperian loop. If you take any Amperian loop inside the wire, inside the pipe, total enclosed current will be 0. So magnetic field B inside will be 0. So correct answer is magnetic field at any point inside the pipe is 0, which is option 3. Next is question number 4. We have a long solenoid has 200 turns per centimeter and carries a current I. The magnetic field at the center is this one, and another long solenoid has 100 turns per centimeter and carries a current I by 3. What will be the magnetic field at the center of the second solenoid? Okay. So we have a long solenoid, so magnetic field formula is mu naught Ni. Mu naught is mu naught, N will be, this is 200 turns per centimeter. So I am keeping it in turns per centimeter only because I will take the ratio. I is I, and this will be equal to what? 6.28 into 10 power minus 2. Now we have one more solenoid and the magnetic field will be mu naught into 100 turns per centimeter. Current is I upon 3 and its magnetic field is B. Take the ratio. Turns per centimeter, cancel, 100, cancel, mu naught, cancel over here. So this will be 6. So B is 6.28 into 10 power minus 2 divided by 6 Weber per meter square, which is equal to option 1, 1.05 into 10 power minus 2 Weber per meter square. Okay. Next is question number 5. We have two long parallel wires and these are kept at a separation r. Okay. And the force experienced by unit length of each wire is F. मतलब force per unit length is mu naught I1 I2 divided by 2 pi r. Okay. If the separation between the wires is 1 by 2 now and current in each wire is double, then the force or new force experienced by each wire will be. So F dash will be mu naught into 2I1 into 2I2 divided by 2 pi r by 2. So this will be 8 times mu naught I1 I2 divided by 2 pi r. But this value is the previous force, so new force F dash will be 8 times previous force 8F. So correct answer is option 3. Next is question number 6. We have a triangular loop and the total current that is flowing through this loop is 2 ampere and it is placed inside a uniform magnetic field of value 1.5 Tesla perpendicular to the plane of the loop, and we need to find the net force experienced by the loop. So over here net force is I L effective into B into sin theta. L effective over here is 0 because if you connect one end of the wire to the another end of the wire, it is same point, right? So L effective will be 0, है ना? So in this case force will be 0. So correct answer is option 4. Question number 7, we have a current of 10 ampere is flowing in a wire of length of 1.5 meter. ठीक है. So 10 ampere current and length is 1.5 meter and the force act on this wire is 15 Newton when it is placed in 2 Tesla magnetic field. The angle between the magnetic field and the direction of the current is, so force is ILB sin theta, where theta is the angle between magnetic field and the direction of current, and that is equals to 15. So sin theta will be 15 upon ILB, which is 10 into 1.5 into 2. So this will cancel this. So sin theta is 1 by 2 and theta will be 30 degree because sin 30 degrees what? 1 by 2. So correct answer is option 1. Next is question number 8. We have a dipole moment of a current carrying loop does not depend on. So dipole moment of a current carrying loop does not depend on. It does not depend on the shape of the loop, current in the loop, area of the loop and number of turns in the loop. So dipole moment is given as NIA. Number of turns depends, current depends, area of the loop depends. So it does not depend on shape of the loop. So correct answer is what? Option A, option 1. Next is question number 9. The current sensitivity of a moving coil galvanometer can be increased by decreasing. So current sensitivity over here is given as NAB upon C. If you can decrease the denominator, you can increase the current sensitivity, and C is nothing but couple per unit twist, right? So over here by decreasing the couple per unit twist of the suspension, you can increase the sensitivity of the galvanometer. So correct answer is option 2. Next is question number 10. We have a voltmeter of resistance 2000 ohms and it can measure up to 2 volt. If we want to increase its range to 10 volt, then the required resistance in series will be. So this is a voltmeter and its resistance is 2000 ohm and it can measure up to 2 volt. So I will be V upon R, that is 2 upon 2000, okay, which is 10 power minus 3 ampere. Now we want to convert this voltmeter into another voltmeter of range 10 volt over here, okay, up to 10 volt. So required resistance in series. So this is 2000, okay, and this is, let's say, R, and current of 10 power minus 3 ampere will flow through this series branch over here, and it should measure the total potential difference across these two combined resistors should be 10 volt. Okay? So V is equals to IR. V is 10, I is 10 power minus 3 and R is effective resistance, that is 2000 plus R. So after solving this one, you will get 10,000 is equals to 2000 plus R, and R will be what? 8000 ohms. I hope this is clear, guys. So correct answer is option 4. You should add 8000 ohms so that this voltmeter can measure up to a potential difference of 10 volt now instead of 2 volts. Question number 11, we have a rectangular loop carrying a current small I and is situated near a long straight wire carrying a current capital I, like this. Okay, and we need to find the direction of movement of the loop because of this configuration. So see, this is the direction of current in this loop. Okay, so this, if this distance is x, then this distance from this will be x plus d if d is the one of the side of this loop. Okay. Magnetic field due to this wire will be into the plane in this region, but the value is what? Mu naught I upon 2 pi r. So magnetic field is inversely proportional to r. In this region, the value of magnetic field in this region, the value of magnetic field is, let's say, this much. Then in this region, the value of magnetic field will be this much only, because r is more for this side and this side, this r is less as compared to this r. So value of magnetic field will decrease with increase in r. Fine. Now for these two wires which are horizontal, so again they will cancel out each other's force, because one force will be, this is I, L cross B, so one force will be upwards, and for this one, sorry, this is the direction, this should be the direction over here, and this one will be I, L cross B, so downward. Upward will cancel downward on each and every point. Okay, but we have two unbalanced forces on this and this segment. So this magnetic field is more, this magnetic field is less. Force on a current carrying wire due to the magnetic field is I, L, B sin theta. For both the segments, the value of L is same, the value of I is same, sin theta will be same, but the value of B is changing, right? B is more over here, so force will be more over here, and in this case force will be less. Now in this case you can see that the direction of current in this and this are in the same direction, so over here will be attraction, and because of this current, like this and this, both are opposite, so between this and this wire there will be repulsion, but force of attraction is more than force of repulsion, so total force will be attractive in nature, so your loop will move towards the wire. Why? Because total force is attractive in nature, right? So correct answer is option 3. Question number 12, the net resistance of a voltmeter should be large to ensure that it should be large so that it does not change the potential difference to be measured. Why? Because potential, if we use voltmeter in parallel, if resistance is very large of this voltmeter, less current will flow through it and most of the current will flow through this branch, and it will not change. There will be some minor changes, but there is no major change in the reading of the voltmeter, because most of the current is flowing through this branch. I into R will be the reading of this voltmeter, which is close to the actual reading, right? Which will be the close to the actual reading if you use the resistance of very high value. So correct answer is option 4. Next is question number 13. We have wire loops P, Q, R, S, P. Okay, formed by joining two semicircular wires of radii R1 and R2 like this. Okay, R1 is smaller and R2 is bigger one, carries a current I as shown in the figure. Okay, fine. So find the magnitude of the magnetic field at the center C. So there are 4 segments of the wire which can generate their own magnetic field at center C. But look at the SR and QP segment. Point P, point C over here lies on the axis of the wire. So because of these two segments, there will be no magnetic field at point C. So only magnetic field will be because of this semicircle of radius r1 and semicircle of radius r2. So over here, if you look at the direction of the magnetic field due to the smaller circle, semicircle will be out of the plane using right hand rule, right. So this will be out of the plane dot, and its value will be mu naught I upon 4r1 out of the plane. This one is, current is like this. So because of the bigger semicircle, magnetic field ka direction will be using right hand rule, it will be into the plane. Fine. So over here the magnitude will be mu naught I upon 4r2, but it is into the plane, right. So you can see that r1 is small as compared to r2. So this must be the larger magnitude and this must be the smaller magnitude. Okay, out of this two. So total magnetic field will be mu naught I upon 4r1 minus mu naught I upon 4r2. So this will give you the correct answer as option 4. Question number 14, we have a current of 0.5 ampere. It produces a deflection of 60 degree in the tangent galvanometer. The current that produces a deflection of 30 degree in the same galvanometer is. So bachcho, we know that for tangent galvanometer I1 upon I2 is tan theta 1 divided by tan theta 2. So over here we need to find the value of I2 for 30 degree. So I2 will be I1 into tan theta 1 divided by tan theta 2. Okay. So I1 is what? 0.5. Tan theta 1 is 60 degree. Tan 60 degree is root 3. No, this should be tan theta 2 divided by tan theta 1. Okay, so tan theta 2 is 30 degree. Let me erase this thing and let's rewrite this thing again. It should be tan theta 2 divided by tan theta 1. Okay, so this will be tan theta 2, tan theta 1. So theta 2 is 30 degree. So tan 30 degree is 1 by root 2 1 by root 3 divided by tan theta 1, which is 60 degrees. So it will be root 3. So this is 0.5 divided by 3 ampere. So correct answer is option 2. Next is question number 15. We have a uniform electric field and uniform magnetic field are acting along the same direction in a certain region. So this is B vector, this is E vector. ठीक है. If an electron is projected in the region such that its velocity is pointed along the direction of fields. So this is electron and it is projected like this. Velocity is parallel to B as well as E vector. Then the electron. So bachcho, over here magnetic force QVB sin theta will be 0 because both velocity vector and B vector are parallel to each other. But electric field will exert, because of electric field, electron will experience one force that is equals to QE. Since this is a negative charge, it will experience a force in the opposite direction of electric field like this, QE or EE. So you can see that this is the velocity vector and acceleration vector, which is force upon mass, EE upon mass, both are anti-parallel. So when velocity vector and acceleration vector are anti-parallel, the motion is retardation. So over here, speed of the particle will decrease. It will decrease, right? So correct answer is option 2. Next is question number 16. We have a square of side L meters lie in the xy plane in a region. Okay. And magnetic field is given by this much. B naught is constant. The magnitude of the flux passing through the square is. So this is x axis, this is y axis, and let's say this is z axis. So we have square in xy plane like this. This is square. area vector of this square will be perpendicular to the plane, something like this. Okay, so this is area vector direction n cap along the z axis. So over here area vector will be area of the square L square into unit vector along the direction of area vector, which is k cap. Then flux is B vector dot A vector. B vector is what? B naught 2I cap plus 3J cap plus 4K cap, right? Dot B vector is L square K cap. So I dot K is 0, B naught times I dot K is 0, J dot K is 0 plus this is 4L square K dot K is 1. So this will be 4L square B naught. So total flux is option 3. Next is question number 17. We have a magnetic flux linked with the coil in Webers is given by the equation 3T square plus 4T plus 9. Okay. Then the magnitude of induced EMF at T is equals to 2 seconds will be. So E is minus d phi by dt. So it will be minus of differentiation of this equation with respect to time. So this will be 60 plus 4 plus 0, which is equals to minus of 60 plus 4. 6 into t plus 4. Okay. Put the value of t as 2 to get the induced EMF ka magnitude over here. So this is 6 into 2 plus 4, which is equal to 12 plus 4, which is 16 volt. So correct answer is option 4. Next is question number 18. We have magnetic flux in current containing a coil of resistance 2 ohm changes from 2 Weber to 10 Weber in 0.2 second. The charge passed through the coil in this time will be. So over here charge passed is delta phi upon R. So delta phi is change in flux, that is 10 minus 2 divided by R is what? 2. So this will be 8 by 2, that is equals to 4 coulomb. So correct answer is option 4. Question number 19. Lenz's law is a consequence of the law of conservation of energy, right? So this is option 1. Question number 20. A magnet is allowed to fall through a metal ring. During the fall, its acceleration is equal to g, greater than g, less than g, or kya hoga? Let's see. So when the magnet is allowed to fall through a metal ring, what will happen? Because of the changing magnetic field due to this coil, there will be some induced EMF, and induced EMF will be in such a way that it will oppose its cause. And because of the oppose, the net force on this magnet will be less than g. Fine, over here. So the acceleration of this magnet which is falling through this metal ring will be lesser than g. So correct answer is option 3. Question number 21. Which of the following figure represents the variation of a particle momentum and associated de Broglie wavelength? So lambda over here is h upon p. So lambda and p are inversely proportional to each other. So their relation will be represented by rectangular hyperbola, which is option 4. Question number 22. The de Broglie wavelength of an electron in the first Bohr orbit is. Okay. So we know that mvr is equals to nh upon 2 pi. Okay. Over here now if you put mv as nh upon 2 pi r, then mv is nothing but momentum, and we know that p is equals to h upon lambda. So over here this is h upon lambda, h cancel, and lambda is 2 pi r divided by n. For the first orbit, n should be 1, right? So lambda is equal to 2 pi r, where r is nothing but 2 pi r is nothing but what? Circumference of the first orbit, right? So correct answer is option 1. Question number 23. The wavelength of an electron of energy 100 electron volt will be. So lambda electron is given as 12.27 divided by under root v angstrom, and v should be in electron volt. So this will be 12.27 divided by under root of 100 angstrom, which is equal to 1.2, approximately 1.2 angstrom. So correct answer is option. Question number 24, the radius of electron in the second stationary orbit of in Bohr's atom is r. The radius of the third orbit will be. So radius over here is what? Directly proportional to n square. So r1 upon r2 will be n1 square upon n2 square. So r2 will be n2 upon n1 whole square into r1. n2 is the third orbit, right? So this is 3. n1 is the second orbit, so this is 2 whole square into r1 is capital R. So this will be 9 divided by 4 into r, and that is r2. So this is nothing but what? 2.25 r, which is option B. Next is question number 25. We have hydrogen atom and it is excited from ground state to the principal quantum number 4. Then the number of spectral lines observed will be. So number of spectral lines observed are n minus n into, let me erase this thing again, right? So this will be n into n minus 1 by 2. So n is 4. So this is 4. 4 minus 1 divided by 2, that is 4 into 3 by 2, which is equal to 6. So number of spectral lines over here are 6. Next is question number 26. We have total energy of an electron in the first excited state of the hydrogen atom is minus 3.4 electron volt. Its kinetic energy in this state is. So kinetic energy is minus of total energy minus of minus 3.4 electron volts. So this will be 3.4 electron volts. So correct answer is option 4. Okay. Next is question number 27. We have speed of electron in the ground state of hydrogen atom is V0. Then the speed of electron in the third excited state of hydrogen atom is. So V is inversely proportional to n, and third excited state is nothing but what? Fourth orbit, right? So over here, if you compare V1 upon V2 as n2 upon n1, so V1 is V0 ground state, so n1 will be 1, V2 we don't know, n2 is 4 and n1 is 1. So V2 will be V0 upon 4. So correct answer is option 1. Question number 28. In thermodynamic process, the pressure of a fixed mass of a gas is changed in such a manner that the gas releases 40 joules of heat. So over here delta Q will be minus 40 joules because it is released by the gas, by the system, and 30 joules of work was done on the gas. So work done is minus of 30 joule because work is being done on the system. So it is taken as negative. If the initial internal energy of the gas U initial is 20 joules, what is the final internal energy of the gas? Okay. So let's apply first law of thermodynamics. Delta Q is equals to delta W plus delta U. Change in internal energy is delta Q minus delta W. Delta Q is minus 40 minus of delta W is minus 30. So this will be minus 10 and this is U final minus U initial. So this will be U final minus 20 is equals to minus 10. So U final will be 10 joule. So final internal energy of the system will be 10 joule, which is option 3. Question number 29. An ideal heat engine working between temperature T1 and T2 has an efficiency eta. So eta is 1 minus T2 upon T1. The new efficiency of both the source and the sink temperature are double will be. So new efficiency is, let's say, eta dash, which will be 1 minus 2 times T2 divided by 2 times T1. We are doubling the temperature of source as well as sink, right? So this will be 2T2, 2T1, 2 cancel. So again we are getting the same expression of efficiency 1 minus T2 upon T1, which is same as the previous one over here. So new efficiency is equal to old efficiency. So correct answer is option 2. Question number 30. The temperature of 5 moles of a gas at a constant volume is changed from 100 to 120 degrees Celsius. The change in internal energy is 80 joules. The total heat capacity of the gas at a constant volume will be in joule per Kelvin. So, change in internal energy is 80, which is N CV delta T. Delta T is 120 minus 100, which is 20 degrees Celsius, and that is equivalent to 20 Kelvin, because change in temperature in degrees Celsius is equal to change in temperature in Kelvin, right. So, no need to convert into Kelvin first and do the difference and everything, right. So, NCV is the heat capacity, which is equals to 80 divided by delta T, which is 20, and that is equals to 4. So, correct answer is option 2. Next is question number 31. We have a mechanical refrigerator. The low temperature coils are at temperature of minus 23 degrees Celsius. So, T2 is minus 23 plus 273 Kelvin, which is equals to 250 Kelvin. And condenser has a temperature of 27 degrees Celsius. So, T1 is 27 plus 273, that is 300 Kelvin. The coefficient of performance is beta is T2 upon T1 minus T2. T2 is 250 divided by 300 minus 250. So, this will be 250 divided by 50, that is equals to 5. So, coefficient of performance is 5, which is option 1. Question number 32. The internal energy U is a unique function of any thermal state, because change in internal energy is a state function. It is not a path function. It does not depend on the process. It depends on the initial and final state of the system, right. So, it does not depend on the path. So, that is why it is option 1 correct answer. Next is question number 33. 1 mole of a monoatomic gas is mixed with 1 mole of a diatomic gas. What will be the gamma for the mixture? So, we can apply mixture of the gases expression over here. So, N1 upon N2 divided by gamma mixture minus 1 is equal to, over here this will be N1 upon gamma 1 minus 1 plus N2 upon gamma 2 minus 1. N1 upon N2, 1 mole each, so it is 1 plus 1, gamma mixture I do not know, minus 1 is equals to N1 is 1 divided by gamma 1 for monoatomic gas, it is pi upon 3, okay, minus 1 plus N2 is 1, gamma 2 for diatomic gas, it is 7 upon 5, right, minus 1, let us solve it. This will be 3 upon 2 plus this will be 5 upon 2, which is 8 upon 2, which is 4, but this is 2 upon gamma mixture minus 1, right. So, gamma mixture minus 1 will be 1 by 2. So, gamma mixture is 1 plus 1 by 2, that is 3 by 2. So, correct answer is option 1, which is 1.5 or 3 by 2. Question number 34. We have diatomic gas at pressure P and the volume V is compressed adiabatically to 1 by 32 times the original volume. Then the final pressure will be, we have diatomic gas, so gamma of the diatomic is 7 by 5, okay. Initial pressure P, initial volume V, final volume is V by 32, final pressure is, let us say, P dash. So, we can apply this equation, PV power gamma is equals to constant for adiabatic process, or P1 V1 power gamma is equals to P2 V2 power gamma. So, over here P2 will be P1 into V1 upon V2 power gamma. So, P2 is, P1 is P, V1 is V and V2 is V upon 32 power 7 by 5, which is P times 32 power 7 by 5, which is equal to P times 2 to the power 5 to the power 7 by 5. 5 cancel. So, we have P into 2 to the power 7, 2 to the power 7 is 128. So, over here final pressure will be 128 times the previous pressure, which is option 3. Next is question number 35. According to second law of thermodynamics, all heat can be converted into work? No. According to second law of thermodynamics, efficiency of any engine cannot be unity, cannot be 100%, right? So if you are extracting some heat from the source, then some work will be there and remaining amount will be rejected to the sink. There is no way in which you can convert Q1 into mechanical work done directly, है ना, Q1 into mechanical work done completely. So first statement is wrong. Second is the efficiency of a heat engine is always lesser than unity. That is true. That is why second law of thermodynamics is here, right? And so third one is it is not possible to transfer heat from lower to higher temperature by itself. Yes, we have two statements, Kelvin-Planck statement and Clausius statement. So these two are nothing but Kelvin-Planck and Clausius statement over here. So according to this one, if you are taking heat from the lower temperature, then you cannot directly transfer this heat to the higher temperature. Natural flow of heat is from high to low temperature, not low to high temperature. So if you want to do the opposite process, you will require some external work done. Without any external work done, you cannot do this transfer from low to high temperature, right? So that is what this statement is, which is again true. So yeah, both B and C are true and option A is incorrect. So correct answer is option 1, 2. Next is question number 36. The wire RS is fixed but PQ is free to move. The wire PQ will have, okay. So this magnetic field is into the plane and its value is mu naught I1 upon 2 pi r. Now the r value is different for different points on this wire. So as you go from P to Q, the value of magnetic field will decrease. Okay. Force on this one will be I cross B. So force on this one will be upwards. So over here, this will experience more force. Okay, I L cross B. Okay, so yeah, since B is variable, so force over here will change according to these points. Fine. So it will translate as well as rotate. Why? Because a net force over here is not a constant. It is continuously changing because the value of R over here is changing, right? As R is increasing, the value of magnetic field will decrease and ILB sin theta will decrease with the decrease in the value of R. Fine. So over here, the wire will perform both a translational as well as rotational motion. Next is question number 37. We have magnetic field at the center of a circular coil, which is B. Okay. This is, let's say, I current, R radius, and B is equals to mu naught I upon 2R. Okay. If the area of the coil is A, then the magnetic moment of the loop is, so pi r square is A, magnetic moment is I A. You can calculate I from this equation, 2B R divided by mu naught into A. And you can calculate the value of R in terms of A from this equation. So R square will be A upon pi. So R will be under root A upon pi, right? So this will be 2B under root A upon pi into A divided by mu naught. So correct answer is 2BA under root A upon pi divided by mu naught, which is option 4. Next is question number 38. We have a thin circular wire and it is carrying current I, has a magnetic moment M. The shape of the wire is changed to a square and it carries the same current. It will have a magnetic moment. So circular wire like this, R radius, 2 pi r circumference, I current, magnetic moment is I into pi r square, I into A. Now I am converting the same wire in the form of square, okay, and having the same current I. Okay, what will be the new magnetic moment? So over here M dash will be, if L is this side, then it is I into L square, but L is unknown. But we know that total length of the wire should be constant, right? So over here, the circumference of this circular wire 2 pi r should be 4L. So L will be 2 pi r divided by 4, which is pi r divided by 2. Okay. So it will be I into L square, which is pi square r square divided by 4. So we have I pi square divided by 4 into r square, but r square from this can be written as m upon I by pi. Pi cancel, I cancel, so we have pi by 4 into m as new magnetic moment, which is option 4. Next is question number 39. The average radius of an air-cooled toroid is 0.1 meter and it has 500 turns. Okay. It carries 0.5 ampere current, then the magnetic field inside it is. Okay. So it is mu naught Ni upon 2 pi r. Mu naught is 4 pi into 10 power minus 7, n is 500, I is 0.5 divided by 2 pi r, r is 0.1. Okay, so this will be 2, this point will cancel this point, so we have 10, so this is 5 into 10 power minus 4 Tesla. So correct answer is option 1. Next is question number 40. In an ammeter, 0.2% of main current passes through the galvanometer. If the resistance of the galvanometer is G, the resistance of ammeter will be. Okay. So we have ammeter and 0.2% of the main current, which is Ig, I into 0.2%. So it is I upon 500. Okay. So this is galvanometer of resistance G. Ig is passing through this. This is shunt resistance S, and current which is passing through this will be I minus Ig. Both are parallel, so potential difference across each will be same. Potential difference is I into R, so we know that Ig into G will be I minus Ig into S. Okay. So shunt resistance over here is S is equals to Ig into G divided by I minus Ig. So this is Ig is I upon 500 into G divided by I minus Ig, that is I minus I upon 500, which is 499 divided by 500 into I. I cancel, this is cancelled, so we have shunt as G upon 499. But we need to find the total resistance of the ammeter, which is parallel combination of G and S, which is equals to G into S divided by G plus S. G is G, S is G upon 499 and it is G plus G upon 499, right. So after solving this one, you will get the total resistance of the ammeter over here as G upon 500, which is option 3. Next is question number 41. A current carrying insulated wire is bent in the form of circular loop and magnetic field at the center of the loop is found to be 2 microtesla. Now the same wire is bent into a loop of 3 turns. The new magnetic field at its center will be. So when we change the number of loops, new magnetic field over here is n square times the old magnetic field. Number of loops are 3. So n will be 3. So this is 3 square times 2 microtesla, which is equals to 18 microtesla. So correct answer is option 2. Sorry. Next is question number 42. We have a long straight wire of radius A carries a steady current I. The current is uniformly distributed across its cross section. The ratio of the magnetic field at a distance A by 2 and 2A from its axis is. So this is long straight wire like this and it is carrying a current I. We have 2 points at a distance A by 2 and another point is distance 2A. We need to find the ratio of the magnetic field at point 1 and 2 at a distance A by 2 and 2A respectively, and radius is A. So when the point is inside, the magnetic field inside is mu naught I into R divided by 2 pi R square, and when the point is outside, it is simple, mu naught I upon 2 pi r, which is 2a. Take the ratio. So mu naught I cancel, 2 pi cancel. So we have b naught upon b outside, bi upon bo is a upon 2a square divided by 1 upon 2a. 2a cancel, a cancel. So ratio will be 1:1. So correct answer is option 1. Next is question number 43. We have a vertical straight conductor carries the current vertically upwards. A point P lies to the east of it at a small distance, and another point Q lies at the west of it at the same distance. So P is over here, Q is over here at the same distance, like this. The magnetic field at point P due to current carrying conductor is, so it will be mu naught I upon 2 pi r. If r is same, the value of magnetic field will be same. So it is same as that of Q, which is option 2. Question number 44. A galvanometer coil is replaced by another coil of diameter 1/4 of the original diameter and the total number of turns as 10 times the original number. What will be the new deflection if the same current passes through it, and old deflection is theta? So over here, deflection is NBAI upon C. Okay. So if you are changing the diameter, you are making 1/4 times the original one. So area of cross section will become 1/16 times, because radius will become 1/4 times and area will be pi r square. So it will become 1/16 times. So theta dash will be n and number of turns are 10. So 10n into b into a by 16 into I divided by c. So this will be 10/16 times NBAI divided by C. NBAI is theta, so this is 5/8 times the theta. So new deflection will be 5/8 times theta, which is option 1. Next is question number 45. We have two long parallel wires. It is separated by a distance of 12 centimeter. Carry electric current 2 and 4 ampere. The distance of null point from the conductor carrying larger current when current are flowing in the opposite direction is. So over here, null point is R upon I1 upon I2 minus 1, right? So R is 12 centimeter, 2/4 minus 1. After solving this one, you will get the answer as 24 centimeter, which is option 4. Question number 46. If the kinetic energy of the particle is increased to 16 times its previous value, the percentage change in the de-Broglie wavelength of the particle is. So lambda is h upon under root 2 me. Now we are increasing the value of E by 16 times. So new lambda dash will be h upon under root 2 m into 16e. So this will be 1/4 times h upon under root 2 me, which is equal to lambda only. So lambda upon 4 is the new lambda dash. So percentage change over here will be lambda minus lambda by 4 divided by lambda into 100, which is equals to 75%. So percentage change is equal to 75%, which is option 2. Next is question number 47. The wavelength lambda e of an electron and lambda p of a photon of same energy E are related by. So over here, lambda e will be h upon under root 2 me. So lambda e square will be h square divided by 2 me. So E will be h square divided by 2 m lambda e square. Now lambda of the photon over here is hc by E. So E will be hc by lambda photon. This E and this E both are equal. Let's equate this and this term. So we have hc upon lambda p is equal to h square divided by 2m lambda e square. H cancel. So we have lambda e square as 1 upon 2m c into, sorry, h upon 2m c into lambda p. So you can see that lambda p is directly proportional to lambda e square, which is option 3. Next is question number 48. We have an electron changes its position from 4 to 2 of an atom. Wavelength of the emitted radiation is. So we have 1 upon lambda is equals to r into 1 upon n1 square minus 1 upon n2 square. So this will be r into 1 upon 2 square minus 1 upon 4 square. So this will be r into 1 by 4 minus 1 by 16, and this will be r. 16 is the LCM, so this is 4 minus 1, and that is 3r by 16, which is 1 upon lambda. So lambda will be 16 upon 3r. So this is the value of lambda in terms of Rydberg constant, and that is option 4. Next is question number 49. In an isothermal expansion at temperature T, the work done in expanding a gas from volume 2V to 5V is W. So W is nRT ln V2 upon V1, 5V upon 2V. The work done in expanding the same gas from 10V to 25V at the same temperature 2T will, at the same temperature 2T will be. Okay. So W dash will be nR 2T ln 25V divided by 10V, and this will be 2nRT ln 5V divided by 2V. So over here you can see that ln V2 upon V1 is same, nR is same, only the change in temperature is there. So work done is directly proportional to temperature of the system. So over here, if temperature is 2 times, then work done will be 2 times. So W dash will be 2 times the previous work done, which is W. So correct answer is option 4. Next is question number 50. Heat energy absorbed by a system in going through a cyclic process shown in the figure. So this is a cyclic process, change in internal energy will be 0. So heat energy is equal to work done according to first law of thermodynamics, right? So work done is nothing but what? This area, and this is clockwise, so area will be positive. So area will be pi into this distance ka आधा, that is 20 into 10 power 3 का आधा into 20 into 10 power minus 3 by 2. So this will be 10, this will be 10, and that is equals to 100 pi. So this is 10 square pi joules, which is option 3. So that is it for today's session, guys. I'll see you again with the next paper discussion, and all the best for your next paper. Thank you so much, guys. Take care, everyone. Bye.